The percentage of the adult population visiting the cinema in Great Britain has tended to increase since the 1980s. The table shows the results of surveys in recent years. The growth may be modelled by the equation of the form P equals AT to the power B, where P is the percentage of adults visiting the population, T is the number of years after the year 1985-86, and A and B are constants to be determined. Part I. Show that, according to this model, the graph of log base 10 of P against log base 10 of T should be a straight line of gradient B. State in terms of A the intercept on the vertical axis. So I am going to take my equation, P equals A T to the power B, and I'm going to take logarithms of both sides. So I will do log P equals log of AT to the power B. I can then use the law of logarithms to split up the right-hand side to be log of A plus log of T to the power B. I can then use the power law to bring that B down to be a coefficient. So it will be B times log T. So let's now compare this to what the question said. It was a graph of log base 10 of P, that's going to be on my y-axis, against log base 10 of T, that's going to be on my x-axis. So the log P, that's my y. My log T, that's my x. So therefore, the B is going to be the gradient, and the C is going to be equal to the log base 10 of A. That is part I of the question done. I have shown that according to this model, a graph of log base 10 of P against log base 10 of T will be a straight line because it is in the form of y equals mx plus c, where the intercept on the vertical axis, c, is log base 10 of A. Right, part II. Completes the table of values and plots log base 10 of P against log base 10 of T. So let's do that first of all. So I've got the table of values up here. I need to do log base 10 of the different values of T. So first of all, typing into my calculator, I'm typing in log 1 and I get 0. Now type in log 6 and I get 0.77815. I'll give this to 2 decimal places, or to 0.78. I'll now do log of 14, which gives 1.15. I'll now do log of 15, which is 1.18. And then finally log of 16, 1.20. I now need to do log base 10 of P. So first of all, we'll start off by doing log of 31, which gives 1.49. Next, we're doing log of 44. Next, we're doing log of 56. Log of 55. And finally log of 57. So I am now going to be plotting these points onto my axes where the log base T, that is on my x, and the log of P, that is on my y. So these are my x coordinates and these are my y coordinates. So first of all, let's plot the coordinates 0, 1.49. Then 0.78 and 1.64 is going to be here. 1.04 and 1.73. That's going to be here. 1.15 and 1.75 is there. 1.18 and 1.74 is going to be there. And finally 1.2 and 1.76. Right, I now need to draw a line by eye for a line of best fit. So let me get my ruler and I'm going to draw a line of best fit through these points. So I want to try and make sure I have the same number of points above the line as below the line, keeping the gradient about right. I think that should be okay. So I've got 3 points above the line there and I've got 3 points below the line. So there is my line of best fit. Part III. Use the graph to find the equation for P in terms of T. Remember that my graph looks like this. Log P equals log A plus B log T. That came from here, where B was the gradient of my line and log base A is the y-intercept. Now I can see that the y-intercept of my graph is 1.5. So I can say that log A equals 1.5, which would mean that A is going to be 10 to the power of 1.5, which is 31.6 to 1 decimal place. The B is the gradient of my line. So to work out the gradient of my line, I need to pick 2 points. I've already got 1 point, which is the 0, 1.5. Let's pick another point that's easy to read off here. I think we'll pick, well, let's pick this point up here. That's the coordinate 1.2, 1.76. So let's work out the gradient of that. So the change in the y, so 1.76 minus 1.5, divide by the change in the x. Excuse me. So 1.76 take away 1.5 is 0.26 divided by 1.2. So the gradient of my line is 0.216. Excuse me. So I've got the value of A, I've got the value of B. I could now substitute them into here, or I could go back to the equation where all of this started from, which is where I already have P in terms of T, which was actually what the question asked for. Find the equation for P in terms of T. So my P is equal to A, which is 31.6, multiplied by T to the power B. That's my answer for part III of the question, my equation for P in terms of T. And finally, part IV, part 4, predicts the percentage of the adult population visiting the cinema in the year 2007-2008, i.e. where T is 22. So we'll use the model, we'll use what we just found, we'll use this equation here with T being 22. So I'm going to substitute that into my calculator. 31.6 times 22 to the power of 0.216 for the occurring. So let's work that out. And we get 61.7%. And there we go.